Okay, 1.3 homework. Real important stuff here. All right, let me bring this in. All right, let's take a look at the graph here. It says use the given graph to state the value of each quantity if it exists. If the answer doesn't exist, enter what? DNE. Does not exist. So I would like to know what the limit, come on, come back. There it is. What the limit as x approaches 2 from the left side, remember that means from the left. So let me get to 2 first. Here's an x value of 2. What I want to do is I want to walk along the function from the left and approach that imaginary dotted line where x is 2. And when I get closer and closer to that, I want to know what the y value of the function is getting close to. And it looks like it's getting close to 3. So that would be 3. Now the difference in part B is that we want to come in on the function on the right-hand side, which means we want to approach that dotted line, but we want to come in from this side and talk about what the y value is. Well, my y value here is getting closer and closer to this, which is 1. So from the left it's 3, right? From the left it's 3, and from the right it's approaching 1. Now it asks what's the limit as you approach 2, and it doesn't tell you left or right. Remember, what this means is that you have to look from both sides. And what you need is for them both to be going to the same place. But we could see earlier that we went to 3 from the left and went to 1 from the right. That means that this limit does not exist. The only way it would exist is if they both went to 3 or they both went to 1. All right, so that's it for that. Okay, let me see. Gosh, I wish I could get that graph on there. What's f of 2? Well, for f of 2, all we need to do is figure out if the function has a value at 2, which I believe it does. Yeah, here we go. Is the function defined at 2? So go out to 2. Do we have a solid dot somewhere? Yes, right here. And that value is 3. So we do have a defined function there. Now let's look at what is the limit as we approach 4, and then what is f of 4? All right. So I want the limit. I'll just leave it. As x approaches 4 of the function, and then I want to know what f of 4 is. So as I approach 4, so here's 4. Here's this like imaginary line that goes through here. As I approach 4, and it doesn't tell me left or right, which means I have to check both. As I approach from the left, I'm getting closer and closer to this value up here, which is 4. And as I approach from the right, I'm headed towards the exact same place, which is 4. Now notice at that point it's an open hole. It does not matter. When we're talking about limit, we don't care what's happening at 4. We're talking about what's happened as we get close to it. So I'm just going to have 4 here. Now what is f of 4? Well, again, if we go to 4 now and we try and figure out, hey, what's the value? There's a hole. So this is undefined or does not exist. The function doesn't exist there. All right. Okay, same sort of tactic here. Let's try this. All right, what is the limit as t approaches 0 from the left? So where is 0? We got to figure out where 0 is. The origin appears to be here. So that's your origin. That's the crossing of the two axes. And now what happens is we approach 0 from the left. Well, let me get a little imaginary line here. I'll kind of put it in yellow. And let's come in from the left. Come in from the left, where are we headed? Well, that looks like -1 down here. So it looks like we're going -1. As I come in from the right side, it's headed down here, even further down, which is -2. And then if I say, hey, well, what's the limit as I approach 0, and I don't tell you left or right, that means these two have to match, which they don't. So this limit doesn't exist. All right, so that's part A, B, and C. So for D, E, and F, what I'm going to do is approach 2 from the left, approach 2 from the right, and then try and approach 2. So what's happening is I approach 2. Where's 2? 2, here's my imaginary line. Approach 2 from the left. I'm headed towards 2. So 2 from the left. That limit is approaching 2. Let me approach 2 from the right. I'm headed down to whatever this value is, which is 0. So approaching 2 from the right, it's headed towards 0. That means the limit at 2 does not exist. And then it asks, what is g of 2? And g of 2, do I have a dot? I do, it's here. And that's at 1. So those are the answers to those questions respectively. 2, 0 does not exist in 1. So 2 here, 0 here does not exist in 1. And then finally, what's the limit as we approach 4? And it doesn't say from left or right. So let's clear this out. So imagine that I have a imaginary line here at 4. So I come in from the left. I'm approaching, what's this value here, 3. So I come in from the right. I'm also approaching 3. And since it's 3 from the left and the right, the answer is 3. The limit as t approaches 4 of this function, g, is 3. Also, it's defined at 4, even though they didn't ask for it. G of 4 would be 3. Okay. Sketch a graph of an example of a function that satisfies all the conditions. So what we want is we want to draw something so that when we approach 0, here's 0, when we approach this imaginary dotted line from the left, we're going to be headed towards 1. Here's 1. So as I come in here, it really doesn't matter how it looks. It's just I need to approach 1. Now, I don't know what's happening there, so I'm going to leave an open circle. Then, as I approach 0 from the right, I need to be headed towards 2. So here's 2 up here. From the right, it's headed towards that. And then at that point, I don't care what's happening, so I'm going to leave it open. And then this says, at 0, my function needs to be defined to be -1. Well, -1 is down here, and I need to define my function there, so I put a solid dot. So which of these would look like that? Not this one, not this one, not this one. Here we go, this one right here. Approaching 1 from the left, approaching 2 from the right, and at 0 we are -1. Okay. Use a table of values to evaluate this limit. So all you have to do here is get very small values. I mean, get your calculator out and just try some stuff. So I think I might just one of these. I don't think I have my calculator readily available anyway. But let's just try something like letting your x approach 0. So let's just pick something like let's let x be really close to 0. How about 0.001? So what we'll do is we'll plug that in here and here. So if I do square root, what's 81 plus 0.001 is 81.001, then -9, then all over 0.001. And we want to do that on a calculator. And you know what? I'm just going to bring up their solution because that's going to take too much time. Did I click it? Oh, they didn't even go that small. They started out at 1, then they went 0.5, and they're getting closer and closer. And it looks like this thing's getting closer to 0.55555 forever, which is 1/18. So that's what it looks like if you do a table. Table again here. Just show it to you. Looks like it's getting closer to 0.44. I mean, sorry, 0.40. So notice they pick values that are getting closer and closer to 1 from the left, so 0.5, 0.9, 0.95, 0.99, 0.999, and it looks like it's getting closer to 0.4. And then they pick values that are getting closer to 1 from the right, so 1.5, then 1.1, then 1.05. So these are getting closer and closer to 1, but from the other side of 1. Either way I come in, it looks like it's getting closer to 0.4. All right, this is going to take some graphing and using a graphing utility. It says graph this function, zoom in toward the point where the graph crosses the y-axis, estimate the value, the limit as x approaches 0. So this you're going to have to do on your own using graphing utility, either graphing calculator at home or use something online like a free graphing utility. Here's a graph. Here's it zoomed in. You can kind of see it's getting closer and closer to negative 1.5. All right, that's going to be it. If you need help with that, just get with me. It's not a big deal.